Okay, so we're going to take a look at how to use logarithm laws to expand logarithms. And so, as we've seen before in other videos or another video, logarithms work along this order of operations ladder. And when we expand logarithms, we move down the ladder. So expanding, the way I like to think of it is I'm starting with one letter, and as I move down, I'm going down to two letters. So I'm expanding when I move in the downward direction. So this direction is expanding. Okay? And exponents become multiplication. Multiplication becomes addition. Division becomes subtraction. And expanding means basically splitting a log, let's say that, splitting a log into multiple logs, perhaps. Splitting a log into multiple logs is what we mean by expanding. Okay, so let's, types of directions you could see in these cases might be something like write as a sum or difference of logarithms, okay, or expand as a sum or difference of logarithms. So that's something like that might be what it is. Or it could just, some books might just say expand, okay? And the idea is to expand as far as possible. So let's try something with this now. We'll start with something that deals with numbers. So like if I have, let's say log base 2 of 8 times 64, we can see that we've got a single log which tells us expand, and when I expand I look inside and I see multiplication. Okay? Multiplication inside my logarithm. When you expand, you're taking something that's inside the logarithm and going to something outside of the logarithm. So I look at my order of operations ladder and I locate multiplication on it, right? Oops. I locate multiplication, which is here. And then I ask, do I move up the ladder or down the ladder? And since I'm expanding is down the ladder. So multiplication is going to become addition. And the log splits, okay? So multiplication becomes addition. So this next step is going to be log base 2 of just 8 plus a separate log base 2 of 64. So my multiplication up here, multiplication became addition down here, and the single log now splits into two separate logs. It's important to do that. You don't just change the times to a plus. You don't have log base 2 of 8 plus 64. That's wrong. If you change the operation, you change the logs also. And now we can evaluate each of these independently. Log base 2 of 8 is 3, because 2 to the third power is 8, plus log base 2 of 64 is 6, because 2 to the 6th power is 64, and 3 plus 6 is 9. Okay, so when you're dealing with particular numbers, you may be able to simplify it quite a bit. Okay, so let's do another example. Let's say we have log base a of x to the 4th power. X to the 4th power. Well, inside we have an exponent. So I know I'm trying to expand. I've got a single log, so I go locate exponent on my order of operations ladder, which is at the very top. And I'm wanting to expand, so I move down, and exponent moves down to become multiplication outside the logarithm. So what happens is, this one's a little bit different. You don't get two logs. This process here, going from exponent to multiplication, does not give two logs. It doesn't split the log apart, but it does create multiplication outside of the logarithm. So what we have is the 4, the exponent becomes 4, times the log that remains, which is log base a of x. Or you could just write it as 4 times log base a of x. You don't need the dot for times, you don't need parentheses around the x, because you're taking log base a of just x. Okay, and that's all you can do with this one. So exponents, when you expand, sort of jump down to the front of the log that they're involved in. And this one gets pretty easy to use. This property gets easy to use. And the third example, let's say we have log base 3 of b over w. And here we have division, and when you expand, division becomes subtraction. So I end up with two things subtracted, and it splits into two separate logs. So my first one's going to be log base 3 of b minus the one that's divided by log base 3 of w. So make sure that when you change division to subtraction, the one you divide by is the one you subtract. And that's all we can do. We can't expand either one of those logs any further. Okay, so now let's try a harder one maybe. Log base 2 of 3x to the 4th y to the 5th. And what we have inside here is multiplication, and multiplication drops down to become addition when we expand. So I have 2 multiplications. So I'm going to have 2 multiplications become addition. So this will be log base 2 of 3 plus log base 2 of x to the 4th plus log base 2 of y to the 5th. So both multiplications became additions, and it expanded out to be 3 logarithms. Now, we're not quite done because we have to look at each of these separately now and see if they expand further. Log base 2 of 3, that doesn't get any simpler, so I leave that one alone. But here I have an exponent, and here I have an exponent, and we know that exponents drop down to become multiplication. In other words, those exponents will jump down to the front of their logs, their respective logs. So we end up with log base 2 of 3 plus 4 times log base 2 of x plus 5 times log base 2 of y. And now, since each log is just log base 2 of something very simple, we don't need parentheses around those arguments, 3x and y. So this would be your final answer. You cannot expand those logarithms any further. Let's try this one. Log of 5a over 4b squared. And you could have parentheses around this. You don't need it. But what we have here is division. And division drops down to become subtraction. So you can see that you've got log of two things that are divided. So I need to separate the thing on top from the thing on bottom, the numerator from the denominator, by subtraction, and it splits to be two separate logs. So I'll have log of one thing minus log of another thing. And as we saw before, log of the top goes first, and then you subtract log of the bottom. Okay? Now, at this point, a lot of people make the mistake of looking at this exponent and bringing it out to the front of that log. But unfortunately, this exponent only applies to b. What you really have in each of these is multiplication, right? This is 4 times b squared. So you've got to separate the multiplication first, and multiplication drops down to become addition. So we'll do this guy first. I'll split this into 2 logs. So I'll get log of 5 plus log of a. Okay? So I've got the yellow one splits to this. And then I'll have this guy over here split as well. So I'll copy down my minus that's in between. And this guy splits as log of 4 plus log of b squared. Okay, so I've got the yellow guy minus the green guy. Now, we do have a slight issue here, and the highlighting here hopefully helps you see it. I need to take the entire yellow thing minus the entire green thing. Before it wasn't an issue because the green guy was just a single log, but now I've got 2 logs added and I need to subtract that whole thing, so I need to put this inside parentheses. Okay, so now we have to look at this and see if it expands further. This one I can't expand, this one I can't expand, this one I can't expand. This one, however, has an exponent which will drop down to become multiplication. Okay, but before I do that, let's go ahead and get rid of all the unnecessary parentheses. So I've got log of 5 plus log of a. To get rid of these big parentheses here, my negative will distribute to the first log and the second log. So I'll have minus log of 4 minus log of b squared. And now my exponent inside this last log becomes multiplication by dropping the 2 down to the front. So I end up with log of 5 plus log of a minus log of 4 minus 2 times, because it becomes multiplication, log of b. And now, even my last log I can't expand further, so I know that I'm done. Okay, in this case I'm taking the natural log of a cube root. Well, there's no exponent or logarithm property that deals with cube roots. However, a cube root is equal to a 1/3 exponent. So I'm going to rewrite this to be the natural log of something to the 1/3 power, and the thing I'm taking the cube root of is this. So I'll have that raised to the 1/3 power. That's the same thing as taking the cube root. And now I'm taking a natural log of something raised to a power. So this exponent is going to become multiplication. In other words, the 1/3 power on all of this is going to go to the front of this log. So I've got 1/3 times the natural log of 5x to the 5th. Now in here I have multiplication. Multiplication drops down to become addition. So I end up with 1/3, and this guy is going to split now to two separate logs. Natural log of 5 plus natural log of x to the 5th. Now, let's back up though. My 1/3 was multiplied by this natural log, which has now been split into two pieces with a plus. So to make sure my 1/3 is multiplied by the entire yellow thing, I still need my parentheses. So I have to distribute my 1/3 to get rid of those parentheses. So I end up with 1/3 times the natural log of 5 plus 1/3 times the natural log of x to the 5th. And then here I have an exponent, and exponents become multiplication. So this 5 is going to jump to the front here. Okay, so I've got 1/3 times the natural log of 5 plus 1/3, and this 1/3 is multiplied by this, so it's 1/3 times, my 5 comes down to the front, so it's going to be times 5 times the natural log of x, which I don't need parentheses now. And all I've got left to do is 1/3 times 5 is 5/3. So I've got 1/3 times the natural log of 5 plus 5/3 times the natural log of x. And I can't expand this natural log or this natural log, so I know that I'm done. So there are many examples of expanding logarithms. Of course, these things can be combined in so many different ways, so make sure to practice with all sorts of problems with these.